Alright, today we're going to be talking about solving exponential equations. So up until this point we have been talking about the properties of log functions. Alright, today we're going to talk about how we can solve exponential equations. So in order to do this, you're going to have knowledge of properties of log functions, so be sure you check out those videos before you try this one. So let's get into our first problem here. And notice here that our variable that we're trying to solve for is where our exponent is. Okay? So what you want to do when you're solving exponential equations, you want to try to get the same base on both sides of the equation. So for example, I have a base of 8 here, and on this side I have a base of 2. I want them to be both the same. Once I have the bases the same, okay, we can cancel them out and solve for what's left over. All right, we're going to talk about why they will cancel out. But first, let's try to get the same base, and then we'll go from there. So I can rewrite this 8 as 2 to the third power. So let me go ahead and do that. So I'll have 2 to the third power, and we have x, right? This will equal 2 to the x plus 6. And now I'm just going to clean this up a little bit. I'm going to rewrite this as 2 to the 3x equals 2 to the x plus 6. Well, notice on both sides of the equation, my base is the same, meaning I can cancel both my bases out. In this case, it will be 2. And what I'm left with will be 3x equals x plus 6. And you can solve from there. However, why does that happen? Why do the bases cancel out when they're the same? Well, this goes back to the inverse property of logs. Okay? So for example, if I were to take log base 2 on both sides of this equation, right? Because what I do to one side of the equation, I also have to do to the other. So what would that look like? If I take log base 2 on both sides, what does that look like? Well, log base 2, okay, and then I'll have 2 to the 3x, and then I'll have equal to log base 2, and again 2 to the x plus 6. Okay. We'll notice here, right, that I'm dealing with a base of 2, and I also have an exponent, right, with a base of 2. So this is the inverse operation, right? They naturally undo each other. So these naturally will cancel out. Same thing, these will naturally cancel out, which is why we're left with just 3x equals x plus 6. Okay? Again, so for example, if I had something like this, log base 8, 8. Well, that's going to equal 1. Remember, I do have an exponent here of 1, okay? This will naturally cancel out, and I'm left with 1. Okay, that is the inverse property. We have talked about that. All right, so knowing that, we don't actually have to write this out every single time. Just know why it's happening mathematically. Okay, so when you're solving for exponential equations, just try to get the same base. Once you have the same base, you can cancel them out. And again, they cancel out due to the properties of inverse, okay, log functions, so inverse log function properties. So let me go ahead and erase this. And we know it's going to cancel out, so we'll be left with 3x equals x plus 6. And let's just solve for x now. So we subtract x, and we're left with 2x equals 6. Divide each side by 2. X equals 3. Alright, so that is our answer there. Alright? Okay, let's try the next one. So the next one, we will have 5 to the x minus 2 equal to 200. So here we go. We're solving exponentials, and we just talked about how we're trying to get the same base on both sides when solving exponentials. Well, is that possible here? And it doesn't look like it is, right? I can't do 5 to a power that's going to give me 200 here. Right? So in this case, we're going to have to go about this problem a different way. All right? So rather trying to get the same base here, all right, we're simply just going to take the log on both sides. So we're going to take the log on both sides. So for example, again, since it's an equation, what I do to one side, I have to do to the other side. So for this side, I'm going to take the log, so I'll have log. And we're just taking log here, so it's naturally going to have a base of 10, right? So just keep that in mind, it has a base of 10. So we'll have log 5, and then we'll do this, x minus 2 equal to log of 200. Okay. Well, go back to your properties of log functions and remember the power rule. Okay, the power rule, remember when we have an exponent and we're dealing with a log, it naturally comes down to the front. Alright, and we talked about why in those previous videos. So let's go ahead and rewrite this now. So again, this whole thing is going to come down to the front, so we're going to have x minus 2, and then we have log 5 equals log of 200. Okay, at this point you want to divide both sides by log of 5. So now we have x minus 2 equals log of 200 divided by log of 5. Okay, so we're going to do this in our calculator. So let's do log of 200 divided by log of 5. Okay, and then once we get our answer, we're simply just going to add 2 to that, right? So whatever our answer is here, we simply add 2, and that will give us x equals. So x equals here 5.29. So x equals 5.29. Right, and that is our final answer. Okay, let's try one more problem here. So let's erase this. And we have 3 to the 2x equal to 27. So 3 to the 2x equal to 27. So again, we're dealing with an exponential equation. We want to try to get the same base on both sides. Well, in this case, we're lucky, we're fortunate, right? We can get the same base. So if I rewrite this, I can write 3 to the 2x equals 3 to the third, right? And again, we just talked about why, okay, the bases will naturally cancel, but in case you missed it, right, we would simply just be taking log base 3 on both sides. So if we did that, log base 3, we're left with 3 2x equals log base 3, and we're left with 3 to the third. Again, these will naturally cancel out due to the inverse properties of logs. Okay? So again, just remember, same base, you can just cancel them out. But again, this is why it's happening mathematically. So if we go ahead and rewrite what we have now, we have 2x equals 3. So very simply, you're just going to divide now by 2. So we get x equals 3 over 2, which equals 1.5. Alright, and that is our final answer. So that is how you go about solving exponential equations.